Hey guys, EM guys are back. So in our first video we talked about cathode ray tube TV. That's a bigger one TV, nobody watches that. So nowadays TV that actually we watch are flat panel display. So flat panel display TVs comprises plasma display, LCD and LED. So in this video we are going to describe the working of a plasma TV. Hey dude, I have a plasma TV in my home which has a resolution of 1080p.
What is resolution?
Oh, you don't know that? For understanding that, you need to understand the pixel. All flat panel displays have a number of pictures element called pixel, which is arranged in the form of matrix. And the resolution is number of pixel in horizontal direction into number of pixel in vertical direction. For color production, each pixel is divided into 3 cells. Pixel size is the distance between middle of one cell and the next cell of the same color.
Operation of a plasma pixel is the same as that of a neon light. Neon, helium, xenon, when subjected to strong voltage, break down into plasma and plasma discharge occurs.
What is plasma?
Plasma is an electrically neutral, highly ionized substance consisting of electrons, positive ions and neutral particles. Apart from conducting current, plasma discharge converts a part of electrical energy into EM waves, which include ultraviolet rays and visible light.
Okay, and how does this plasma useful in TV?
Phosphors, which emit different colors when excited, are used to cover the inside of the pixel. The ultraviolet rays that are generated in the discharge impact on the phosphor coating to emit color light. The figure that is shown on the right is called a coplanar panel. It consists of a scan electrode and a common sustain electrode. The plasma discharge occurs between these two electrodes. How does a pixel cell work?
Well, driving a pixel cell involves 3 phases. First, set or erase phase. Second, address or write phase. And lastly, sustain or discharge phase. These 3 phases are repeated sequentially.
First, let's talk about set phase. A step pulse of about 300 to 400 volts is applied between scan and sustain electrodes. It causes a small discharge and the gas in the cell becomes ionized. It results in erasing any residual charge that has remained from previous cycle. Once a cell is cleared, the scan electrode is taken to a negative potential by a scan pulse. If the data electrode is activated, the cell is chosen for emission. This discharge gets quickly cleared as the dielectric surrounding the electrode charges up. This charge on the dielectric is responsible for a plasma discharge. The pixel cells that do not have a charged dielectric will not produce light in the sustain phase.
The final stage is discharging and light emission. A high frequency pulse is applied between scan and common sustain electrode. The charge on dielectric increase causing plasma discharge to occur. Emission of UV rays and their subsequent bombarding of phosphor coating causes color glow. This set address discharge process is known as address display separated ADS, in which addressing takes place first and then the pixels are displayed by a simultaneous discharge. Okay, so from this video we got to know that the main difference between cathode ray tube and plasma TV operation is in emission and phosphorus excitation. In cathode ray tube, emission of electron beam takes place in a dot sequence, and in plasma display, UV rays are emitted simultaneously. Okay guys, this was it for today.